All right, so section 1.1, patterns and inductive reasoning. So here's our attempt here at a flipped classroom where you watch the video and then you do all your homework, all the problems in class. Um, and so here's our first example. We're going to sketch the next figure, and you just kind of have to see the pattern, and I kind of see that this square is going to here, going to here, so I can see it's kind of a um, counterclockwise rotation of 90 degrees each time. So I can sketch this is going to be on the top this time, and this piece is going down. It's 4 pieces long, and then 2 pieces this way. So kind of just a visual pattern there. Our next example will be number patterns. Different ways to do this. Oftentimes I look for what I'm adding or subtracting. What's the difference between um, these two consecutive terms? So 17 to 15, I took 2 away. 15 to 12, I took 3 away. 12 to 8, that's 4. So if I'm going to predict the next number, I'm going to take 5 away, which would give me 3. Um, Now, do be aware that, like on the test, it says you'll have to predict the next 3 numbers. So don't just predict the next 3 numbers. So it would be like subtract 6, and we'd end up with -3, and then subtract 7, and that'd be -10. Here, now 48 to 16, you could figure out your difference. And then 16 down to 16 thirds, I'm like, okay, how did that happen? 16 thirds to 16 ninths. Well, if you're notice that you're not going down by the same amount. All right, sorry about that interruption. Like I was saying, we're not going down by the same amount, so I'm thinking, what am I multiplying by or dividing by? So I can just take 16, this number, and divide it by the previous term. 16 divided by 48 would be 1/3. So that's what I'm multiplying by. I'm multiplying each time by 1/3, and that's a little bit easier to see here. It explains that. Remember, when you multiply straight across. That's why the denominator went up to 9. So my next term, if I multiply by 1/3, I'm going to get 16/27. In geometry, we're going to be doing a lot of um, reasoning. It's a very important skill that you'll probably take out of geometry. There's 2 different types of reasoning: inductive, which we're going to talk about in chapter 1, and then deductive, what we'll talk about in chapter 2. Inductive reasoning is looking for a pattern. That's the key part. Okay, look for a pattern, and then we can make a conjecture. Conjecture is just basically um, a statement that we believe to be true, and then we're going to verify that conjecture. So complete the product of any 2 consecutive positive integers is, well, let's look for a pattern. Okay, let's start by looking for a pattern. I might say well, product means multiply. 2 consecutive means in a row. Positive, they have to be positive. Integers are those counting numbers and their opposites. So like 1, 2, 3, and their negatives, 0, -1, -2, -3. So no decimal or fractions here. So consecutive integers like 1 and 2, if I multiply those together, I get 2. Well, the next pair is 2 and 3. Multiply those together, and I get 6. 3 times 4 is 12. 4 times 5 is 20. So what do these numbers always have in common? I see that they're even, and does it make sense? And to me, it does make sense because I'm always going to have an odd times an even. An odd times an even will always give me an even number. Show a conjecture is false. To show a conjecture is false, we're going to do a counter example. So the difference of two positive numbers is always positive. Difference means subtract two positive numbers. So I'm going to have, say, 4 minus 1. All right, those are positive numbers. The difference, well, the difference there is positive. So that does not show this is false. That shows that this statement is true so far. To show this statement is false, I need one example, just one example where it's not true. So I'm going to come up with a counterexample of maybe 1 minus 4. 1 minus 4 is negative 3. So the difference of two positive numbers is always positive. Well, right here, that statement is false. And it's false because of this counterexample. Okay, so you could say 1 minus 4 is negative 3. Negative 3 is a negative number. That statement is false. We'll skip over that one. Last example, an observer notices that during the evening commute, buses arrive at a particular bus stop at the same time each day. Use inductive reasoning. Inductive reasoning means patterns, and the information below to make a conjecture about how often the bus comes. Okay, so here's when the bus comes. We have 4 times. We want to look at a pattern. Well, I'm looking for a pattern. I might say how often is it coming? Well, from 5:15 to 5:38. 15 plus 8, 23 minutes. From this time to that time, if I add 23 to 38, remember at 60 it moves to the next time, and that would be 6:01, add 23 again. So my conjecture will be a bus, get rid of this here, move this over here. A bus comes every 23 minutes. And there's the homework that we'll work on in class tomorrow. Okay, so you don't have to do that tonight, but that would be something you would want to write down in your notes. Do remember that you can use your notes on the test. Feel free to, if you didn't understand one of the examples, pause it, go back, take good notes, write down the examples in your notes, and use those on the test to do well. So everybody have a good night, and we'll do this homework in class tomorrow.